Okay, so we'll proceed on capacitor based oscillator, and what we have seen till now is it works as a capacitor initially behave as short circuit and then open circuit. Okay, if we see the kind of charging curve, capacitor charges from the voltage source through this path. Okay, and then it discharges through this path. Okay, so capacitor charges from both paths, so I think that would be better explanation. Okay, so capacitor is kind of getting charge from this path also, because voltage from this path also. Okay, so it is getting charge from this path also. Okay, so voltage source, so this is kind of reverse bias, so the impedance would be high, and being this forward bias, the impedance would be less. So it is getting charge from both directions, and when capacitor is charged and it has to discharge because the sink is in this direction. Okay, so this makes a loop and it would discharge, so making it forward bias, so discharge would be very quick. It's a 10 kilo ohm resistance, and here 330k and whatever the resistance this path is showing. So parallel we can kind of calculate, and plus 10k, so that much resistance it is getting when it is charging. So two paths are there, charging and discharge. Okay, so now we'll see kind of we'll see kind of the circuit from the close view. So that is the first idea. Okay, so I'll show the kind of circuit diagram. So it is oscillating. So from little closely how it is connected. Now we have a capacitor, and we can see there is a wire. So we'll kind of check it as if it is can behave as a rain alarm. So that we'll see. Okay, now we'll see kind of we'll simulate a rain alarm. So we'll have a rain alarm probe, and that will be connected from here. So we disconnect the circuit and connect a rain probe to wire, and we'll put in a kind of water, and we'll see it really oscillate. So kind of keeping 1 microfarad as a capacitor. So that we'll see. Okay, so this is the kind of circuit connected, and we can hear the oscillation sound. So now we have connected kind of 4.5 around 4.7 microfarad capacitor. So frequency is less. So those things we'll calculate later, and how much time it should take and what is the value of resistance and those things. Okay. Now, okay, so this is the speaker, this is the circuit, this is the battery, and battery voltage we have already shown, it is around 2.59 volt. So 330 kilo ohm resistance we have taken out from the base, and in between we have inserted one kind of a probe that we can see. Okay, so it is connected, so it is kind of oscillating. Now we will disconnect it, so we disconnect it, so there is no sound. Okay, so if I connect it again, there will be sound. Okay, now we'll see if it behaves as a kind of a rain alarm. So I have water to test. So I'll place inside the water and we see that if it really oscillates. So one probe went inside the water, another probe is going inside the water. Okay, so it behaves very well as a rain alarm. So if it kind of water is behaving like a conductor, and when they come in touch through water, so it starts oscillating. There is no change in frequency and there is no change in sound also. Okay, if I take out one probe out of the water, sound goes away. I place it again. Okay, if I take out both out, no sound, and if I connect it together, okay, so there is sound again. Disconnect, no sound. Okay, now whatever frequency we are generating, we are seeing, so those will analyze. So this is to kind of show that it behaves good as a rain alarm. Okay, and if so if we see the circuit, then two transistors we have used. One is this transistor, another is this transistor. Two transistors are used. So this one is PNP and this is NPN. This is 330 kilo ohm and this is 10 kilo ohm and this is 4.7 microfarad. Okay, we'll measure what it is actually. So that will do that. Okay, so we have seen now rain alarm. Now it's time to go for kind of various other capacitors. So 1 microfarad we'll see, then 4.7 microfarad, 10 microfarad and 220 microfarad. So 220 microfarad, that the charging time would be kind of very high, because 220 microfarad comes as 0.22 millifarad, and then multiplied by the parallel circuit, what we see charging curve from this direction and this direction. So that parallel will compute, but still it will be very high. Okay, so charging will be very high and discharging will be less, but still it will be, because it is 220 microfarad. 10 will be quite less, 4.7 less, and so 4.7 and 1 microfarad means it will be really quicker, in the sense that charge discharge will be quite fast, whereas 10 microfarad it will be okay, and 220 will be pretty slow. So that we'll see now. Okay, so we'll see it is oscillating now. Okay, so we will, maybe I can place it near the speaker. Okay, so it is oscillating. Now we will measure the oscillation. So this is with 4.7 microfarad capacitor. Okay, so I'll take it out. Okay, now I'll put 1 microfarad capacitor. So frequency is high because 4.7 and 1 microvolt charge and discharge is quicker. So we can see the difference. Okay, now I will change it to another picture. So I have one 10 microfarad capacitor. Okay, so first difference is that frequency is low, and second thing is that audio is not continuous. Earlier audio was continuous, now it is not continuous. Yes. Okay, so it taking time to charge the capacitor. Discharge is quicker, okay, because 10 kilo ohm resistance through which it is discharging, so it is quicker. But charging is 330 kilo ohm, and since it is a 10 microfarad capacitor, so that is kind of, it is means it is noticeable that it is taking time. Okay, so I will connect the bigger 220 microfarad. Okay, so there is no oscillation. Okay, so there is no oscillation, or it is we are waiting if it is really oscillating after some. Okay, so there is oscillation, but we can see that time taking is very high. There was some two sounds are quicker, means that is when it is discharging. Now it will take long time. Okay, so it is clear that everywhere it is same. If I had connected a 10 microfarad capacitor, then two sounds were quicker and then third was very long, then again quicker, then third. So charging and discharging happening through different resistance, and that much time gap we are seeing. Okay, so we have seen the kind of charging discharging for the 1 microfarad. So Audacity is a kind of audio editing tool, and there we have kind of taken the graph. So we can see it is 1.09 second and 1.21 second. So within 12 seconds, so 1 microfarad, how much charge discharge it takes. So one double line is kind of, so if gap is big, can we see? If gap is big, then this much time it takes to charge and discharge is smaller. So if I take one, how much charge it takes? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So probably within less than 4 seconds, 23 times it is charging and discharging. Whereas for the kind of 4.7, okay, so it starts from around 2.01. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 11. So within 9, 2.01, within 8 seconds, around 11 time it is charging. Okay, so that is, so more computation will do. Okay, now with the 10 microfarad and 220 microfarad. So with the 10 microfarad, we can see it starts the story from 1 minute 42 seconds, and then within 8 seconds, 1 minute 54, 3, 4 and 7. Within 8 seconds, kind of 7 times it oscillates. Okay, and Mr. 220, it takes a lot of time. So if I say that it starts at, okay, so it is around, I believe, 4 minute 37 second, and then 6 minute 30 second. So around 2 minutes it takes to oscillate 4 times. So it is quite slow. Okay, so now we will see that we have added in the circuit the collector of the PNP transistor. This is PNP transistor, is connected kind of near a speaker. So can we connect it to sink and let it charge and discharge through this base only? So that we will see. Okay, so here we will kind of connect the capacitor, the collector, okay, to sink, and then we will see how it is. Okay, so we are seeing the kind of heartbeat. So we'll see what is the scenario if I take out the collector, the PNP collector we have connected to the speaker, and if I connect it directly to the kind of sink, what will happen? Okay, so no sound. So if collector is connected to the sink directly, not to the speaker, there is no sound, because the speaker is it is charging and discharging through the emitter of the NPN, but it receives energy from the PNP transistor, and through that energy it is kind of oscillating. So I'll connect it back to the speaker. Okay, so collector must be connected to a speaker, because the speaker receives a power from the collector and of the PNP, and that's why it is making the sound. That power is missing. Okay, so that power is missing. If I connect directly, and now power is available. Okay, so that is energy of the collector. Now we will measure the kind of each resistance. Okay, I have brought a multimeter. Okay, so we can take it out. Okay, so we'll measure the resistance. I hope it is visible. Okay, so first we'll measure the 10 ohm. So it should be 10 ohm. Okay, so it is 10 kilo ohm resistance. Okay, this is one of another we'll measure. It is around 300 kilo ohm, 310.